Hello everyone. In this lesson we're going to talk about the basics of using vectors in C++. So first, a vector is a lot like an array and how it's used in coding in C++, but vectors overcome some of the limitations that arrays had, including that arrays always had established sizes that you could never change within a program when it was running. Vectors, on the other hand, can be resized within the code of a program, and it's also very easy to add elements onto the end of a vector, unlike onto the end of an array. Once you establish the size of an array, you can only use that many elements. So if you encountered a situation where you needed one more element, you'd be out of luck at that point. So to use vectors, we first need to include the vector library up here with our other include statements. So we'll hash include the vector library. And we'll begin by just declaring a vector that's capable of holding, say, 3 elements. So we first write the word vector, type the word vector, and then in angled brackets, we'll put the vector's base type, which could be something like int or double, or even the type of a class or a structure that you have in your program. It could even be a vector of strings at this point. And we'll begin with a vector of ints for this. So we'll say it's int is the base type. Then we'll give our vector a name. We'll call this numbers. And at this point, you could either terminate this declaration and then start adding values onto the end of the numbers vector as you were going through the program, or establish a size. So we'll say this numbers vector has a beginning size of 3, which we'll put in parentheses here. So that's one variation from the syntax with arrays, is that the size of a vector when you're declaring it, if you choose to establish a size, is put in parentheses instead of square brackets. Now, when you're referring to the individual elements of this numbers vector, we will be using square brackets just like arrays. So let's assign the 3 elements of this numbers vector as values just to show that. So we'll do numbers square braces 0 is 10, numbers square braces 1 is 20, and numbers square braces 2 is 30. So just like arrays, vector indices begin at 0 and must be less than the size of the vector. And again, we use square braces just like we would arrays. So we could show what these values are through a for loop, print them to the screen. Again, very similar to arrays. We'll make a for loop here. We'll say int I equals 0. We'll keep I less than 3, since that's the size of a vector, and then I++. And then we'll see out the ith element of the numbers vector, which would be numbers square braces I, put a space for formatting, and a new line here. So just to show that that correctly assigned 10, 20, and 30 into the numbers vector, let's run this. Okay, great. So it just iterates through and prints 10, 20, and 30. Now, one way to also control this for loop is one of the member functions that's in the vector library called the size function. So just to show that, we could have changed the 3 to be this function call to numbers.size with parentheses here. So this size function returns an int that represents the number of elements that are in the numbers vector. Now, granted, we knew the size of this vector was 3, but as we go through and code with vectors, this size function is going to be very, very useful, especially if you're going to be changing the size of a vector throughout the program. It's a very useful way to refer to how many elements are in it. So again, to run this, it does the exact same thing we had before, and it knows that there are 3 elements in that vector. Okay, so at this point, let's say we wanted to add additional elements into that numbers vector. We could do that in a couple of different ways. We could resize the numbers vector and then assign values to the additional elements. So there's a member function called resize that we could call that would change the size of this vector from 3 to whatever we wish. So let's say we wanted to put in 2 additional values. We could do a call to the resize function. So again, we're using the vector name here, numbers, using the dot operator and calling the resize function with an argument of 5. And now that would allow us to refer to 2 more elements in the numbers vector. So we could do numbers square braces 3, we'll say that's 40, and then numbers square braces 4 is 50. So again, this allows for 2 more elements that we could refer to, and would allow us to dump in 2 more values like we did there. Now, another way to put additional values into this vector is also this function called the pushback function. And this one's extremely useful, and you want to get used to using it. So that simply just adds an element onto the end of the vector and changes the vector size to allow for that. So let's say we wanted to put the value of 60 into this vector. We could do it as follows. We could say numbers.pushback. So again, the function is called pushback, push_back, and then put in the value we wish to put onto the end of that vector, which would be 60 in this case. So what that does is puts the value of 60 into an element whose subscript is 5, and then changes the size of the numbers vector to be 6 to allow for that. So that's very, very useful and versatile. And we'll show using the pushback function in a more typical example after we get through this basics. So again, now let's print out all the values in the numbers vector again. So I'm actually going to copy this for loop that we had here. And this should correctly iterate through the entire vector. So it's int I equals 0, since the first subscript is 0. We used numbers.size to control that for loop. After we initially used 3, we changed that to numbers.size. And this should return the number of elements that are in the numbers vector. So again, very useful to use that to control this loop. And it should print out 10, 20, 30, 40, 50, and 60. Build and run. Okay, so first for loop prints out 10, 20, and 30. And that second for loop prints out 10, 20, 30, 40, 50, and 60. Again, after we resize the vector to now have 5 elements, put in the values of 40 and 50, and use the pushback function to add the element with a value of 60 onto the end of the vector. So that call to numbers.size is returning 6, since there are 6 numbers or values in that vector. Okay, great. So again, you may not be using the member functions in quite the way we were doing here. It just shows you the syntax of calling the size function, the resize function, and the pushback function. So let's code a more typical situation that would lend itself to vectors, which is, say you're taking input from the user, and you don't quite know how much data you're going to get from the user. Oftentimes this was a situation we encountered where, who knows how many numbers the user is going to enter for a given situation. Say you were finding the average test score in a class, and you were trying to write a program that's versatile from class to class. You never quite know how many students are going to be in each class for that. So one way to do this is to have a loop that allows the person to keep entering numbers and then just uses the pushback function to add those numbers into a vector. So let's declare a brand new vector. We'll say it's a vector of doubles. So we'll use vector base type double, and we'll call this data. And we will not establish a beginning size this time. We'll just declare this vector called data. And we're going to give the user directions to enter positive values and then to enter a negative when they're finished. So we'll say, please enter positive values below, enter a negative when you are finished. So that's a very similar structure we've used to control input before. And let's see, we'll also introduce a double variable, a normal double variable, to hold on to the individual values the person inputs. So we'll do double num, let's say. And what we want to do is write a loop that allows the user to continue to enter positive values. We'll store them in the data vector, and that loop should end once the person enters a value that's negative. So we'll use this as a do-while loop, let's say, to accomplish this task. So to control this loop, we'll use this variable num. And we'll say this loop should repeat as long as num is greater than 0. So that means the person is not done entering input. And the first step of the loop would simply just ask for the value of num, or allow the user to type in the value of num. Then, provided num is positive, that value should get added to the data vector. So we'll say if num is greater than 0, we want to put the value of num into the data vector. So the way to do that would be to use the pushback function. So right now, the data vector has size 0. However, once we start using the pushback function, it will resize the vector to allow for as many positive values as we wish. So we'll do data.pushback and then num. So when you get a positive value, this call right here, data.pushback, will put that positive value into the data vector. And it will allow you to continue doing that for as many positive values as you wish. So that's not assuming that there's some maximum number you could input. This would allow for as many positive values as we wish. So again, that's part of the versatility of using a vector as opposed to an array for something like this. This same task with an array, we would have had to think of a maximum size and also track the size as we were going along. This pushback function pretty much takes care of the issue of not knowing how much you're going to get. And then there's also the size function that we could use to print out all the values once they're stored in that data vector. So let's also just to show this works correctly, print out all the values that are stored in that data vector once this is done. So we'll say cout, here are the values you entered. And again, this should not echo the negative value. So this loop structure here, I think we have set up to where the negative value would not get stored in that data vector. So we'll do for int I equals 0. We'll keep I less than the size of the data vector, which would be data.size. Again, we'd use parentheses next to size since that's a function call. And then I++. And we'll just cout the ith element of the data vector at that stage. And space for formatting, and then an end line. So again, this block of code right here is intended to basically allow you to enter as many positive values as you wish. Could be 5, could be 10, could be 100. And then just echo them to the screen. And granted, you could go much further than what we have here too. You could sum all those values pretty efficiently. You could find the average of them. And this gets beyond a lot of the limitations that we used to have with vectors in a situation like this. Or I'm sorry, arrays in a situation like this. Again, vectors are a lot more versatile. So let's run this again, build and run it, and see what happens. So again, there's the beginning, 10, 20, 30 from our first example we did. Now here's the beginning of that do while loop. Please enter positive values below. Enter a negative when you're finished. So the data vector was allowing for doubles. So we'll do some like test score values, 74.5, 81.7, 92.3, 79.1, and we'll say be a perfect 100. And then we'll enter a negative value when we're done, -1. So that do while loop correctly processed the input from what we can tell. It stored those 5 positive values into the data vector. And then the for loop here iterated through the data vector, again using data.size, and printed out the 5 positive values that the user entered. So again, this code example right here is very, very important to understand. The way you're going to be coding with vectors might often use very similar logic to this. Declaring a vector, using the pushback function to just simply add elements onto the end of the vector, and then using the size function once you're eventually working with that vector. So again, that's the basics of working with vectors. There's a lot more member functions in the vector library than the ones we talked about. The pushback function, the size function, the resize function are all very useful. There's other ones as well. You can delete elements from a vector. So I think the practice you'll be doing might direct you to c++.com to look up how to use them. That's oftentimes your best resources to, again, look in the textbook or simply just go to the c++.com resource and find an example bit of code where somebody was trying to do essentially the same thing you are with a vector.